Good day, guys. Alright, so in this video I want to talk about 2.2 kinematics equation, and I want to show you guys how you can derive three equations. Here are the equations. Those three equations using calculus. Alright, okay, so obviously the first one talks about velocity, acceleration, and time. The second one talks about displacement, initial velocity, time, and acceleration. And then the last one leaves out time as a variable and just talks about how velocity changes with displacement, or how displacement changes with velocity. Right? So before we begin, I would like to lay out three assumptions. Right? So what are those assumptions? Okay, we need to know what framework are we working with. All right, so the first of those assumptions is that acceleration is constant. That means delta A is 0. There is no change for the acceleration at the beginning until the end, whatever. All right, at no point of the motion does the acceleration change. Now the second assumption, or the second point of framework, is that at time t equals to 0, the velocity is vi and the displacement is si. Okay, now for the third thing that we should keep in mind would be at time t, so it went from 0 until t, the velocity is v and then the displacement is s. All right, okay, so let's begin. All right, so the first of those equations we can derive beginning from the definition of acceleration, which is dv over dt. Okay, what we can do in less rigorous mathematics manner is that we can take, or we can multiply both sides by dt. Okay, all right, so a dt equals to the integral dv. Okay, now because a is a constant, because it doesn't change, right, we can take it out, but let's put the limit to it. So we start with 0 until t, and then at time 0, right, v is vi, okay, and then at time t, velocity is v. All right, so we can integrate that, we can take it out. So a 0t dt equals to the integrand of vi dv. Okay, so that is merely at, and on the right hand side we have v minus vi. Bring the vi over to the left hand side, and what we have is v equals to vi plus at. Okay, so that's our first equation. All right, so our second equation, s equals to si, which is the initial displacement, plus vi t plus half at squared. So how do we calculate that? We can start with v equals to ds, displacement, over time, or dt. Right, again what we do is we multiply both sides with dt, and what we get is v dt equals to ds, and then we can integrate that within our limits, so 0 to t, and then from si to s. Okay, now keep in mind this v is a function of time according to the first equation, so we can take the first equation, substitute it in, so 0t vi plus at dt equals to s si ds. All right, so we have to integrate that. So what we will have is vit plus half at squared. Okay, that would be equal to s minus si. Now again, bring this si to the other side, and what we have is s equals to si plus vit plus half at squared. Now what I want to point out at this point is that displacement is a function of time, in the sense that it is best described by a polynomial, right, of a quadratic nature. Okay, so what we have here is that if we were to draw this out, we will have a parabolic path. Okay, now the last one which is v as a function of displacement, is a bit more tricky. All right, at this point you'll actually see how important is 1. Okay, so as before, we have used a equals to dv over dt, right? We have also used v equals to ds over dt. Why? Because for the first equation, which is this one, we wanted v as a function of t. Second equation, we wanted s as a function of t. Okay? So now what we want is dv over ds. Okay? Now, of course, we don't have any definition, so we can't start from definition, but what we can do is multiply it with dt over dt, which is just 1, right? It equals to 1. 1 times a is still a. Okay, so that means a is also equals to a times t over t, right? And I can shift it around. I can change the ds and dt, and what I will have is dv over dt and dt over ds. And by definition, dv over dt is just a, so that's a, and dt over ds, so which is this one, right? What I have is 1 over v. Okay, so at this point what I will have is, let me write that down, dv over ds is equals to a over v. I can rearrange them and have v dv equals to a ds. Okay, now again we can integrate both sides with our limits vi and v, and then I can have s and si. Okay, so on our left hand side I will have v square minus vi square multiplied by half, okay, which is equals to a s minus si. Okay, I can rearrange that, right, to get v square equals minus vi square equals to 2a s minus si, right? And then I have v squared, the final form, which is v squared equals to vi squared plus 2a s minus si. Okay, so that shows how we can derive the 3 equations up here using calculus. All right, that is all for this video. Thank you very much.